Yeah, that was, Todd, that was interesting because, as you know, I did tons and tons with lifters. It's just flashback time. Yeah,
Yeah.
the thinner wire gauge makes less noise. I ended up going to 50 gauge, and then in my case, I went to stainless steel Corona wire. It turns out this is just something that I had seen. Copper, that was easier to get when I first started, interacts with the air. There's a chemical reaction that makes a heck of a lot of noise.
Yeah.
So the
Well, that's
stainless,
stainless steel wire that was singing like that.
yeah, yeah.
And, but yeah, I didn't see 50 gauge, or I would have got that. 40 was the smallest I could find.
The place
So,
that I used to buy that was from Information Unlimited. That
okay.
was, and they may still sell it. It was like an off, I don't know what you would call it. I would just give them a call and say, hey, do you guys have any? And they didn't always have it, so I would kind of stockpile. But
What kind of improvement did you see using that?
so basically, when you go from thicker of any type, when you go from thicker to thinner wire gauge, your noise level drops. And at 50 gauge, you can hear ions coming off it, but you can't hear the wire at all. You don't hear any kind of vibration or singing or anything like that. And so instead of, I mean, you've always got that hiss, right?
Yeah.
Yeah. And so the wire noise goes away. You still hear the hiss. The hiss is more pronounced. I played around with a ton of stuff. So the temptation is you get a lot higher ion output with 50 gauge. So it's tempting to try and put a bunch of those wires near each other, right? To run them in
Yeah.
parallel. Yeah. And the E field smooths out. And so I had problems with that because my first thought was, okay, I'm going to make a grid and it's going to do tons of ions, but the E field smooths out and it actually doesn't work as well. So
Yeah. I tried to keep them far apart to just spread it out over more area. But yeah, I know that too. That's why I went to the spikes, because what it does with the Tesla coil, it shoots the arcs sideways because the one in the middle is repelling the ones around it. So that's why I did this design, because I want the arcs to go out sideways so that the disc has time to repel it.
now, I did have I have one anecdotal story. We had a bunch of little stuff, but one that reminds me, your lifter reminds me of this. I built in my case, I tested a I don't know what you call it, almost like a scalar antenna. I think that was what it was. It was basically like a donut where it had two rings. So it was, the whole thing was flat. It was actually on like a paper plate. The outside ring was, I think, my collector, and the inside was the other charge. And then they had like an inch between them. And the idea was, I thought, well, what would happen if I could make ions flow between these? What would that do? And so I didn't really see any results. So I figured, okay, well, I'll hang this thing sideways, right? And I had it hooked up to, it was on a 50,000 volt power supply. When I turned it on, it was suspended by one of the power leads, and I think the other one was just coming off as a ground. So the interesting thing was not movement. The interesting thing was this thing was suspended by one wire, and just in the breeze of the garage, it started to turn. And as it turned, I had my hand on, I had the camera and I had my hand on the power supply. And as it turned, this thing panned across my body, and like in the line of sight, right? Like it was producing a beam. And the beam went down one arm, and I could feel the hair just where this beam was hitting come up on the arm. And I was probably like 4 or 5 feet away from this thing. And then it went down to the hand that was touching the power supply. And when it hit the power supply just shorted out and went dead. So I don't know. And that's what the standard, basically just a Cockcroft Walton, voltage multiplier.
Yeah. So, yeah, like I said, my goal in this is, and the reason I refer to it as an arrow warp spike is because in a warp drive, you think of space-time in front is contracting and space-time behind is expanding, or that the universe in front of you is pulling you forward and the universe behind of you is pushing you away. And so the objective here of having a negatively charged disk and a negative ion cloud behind it and a positive ion cloud in front of it is that same kind of principle, is that the positive ions are going to attract the disc forward while the negative ions behind it are going to push it away. So it's an air breathing warp drive, is electromagnetic warp drive is my concept here. I don't claim it'll go faster than light. I don't even claim it's going to give me propulsion, but I'm going to try and see what it gets. You know.
Yeah, no, that's, sir, let me take some questions here. And I better read our question and answer thing. So it is Alt Y and Option Y on Mac or Alt Y on Windows. For anyone who has questions, I know you're all dying to ask them. There's Chris. Chris, sir.
Hey, Chris.
Oh, you know what? Sorry. Now you can unmute yourself.
Hey, here we go. Cheers, Tim. Yeah, no, that was a great presentation. Thanks. I've been really interested in lifters for a while, like a long time, probably sort of 2000s. I've never actually got to get one to fly yet. I think it's probably the power supply issue, like just ramping it up as I get older and maybe less wiser with high voltage. No, I just had a quick question about sort of the force readings you were getting, because there's obviously sort of the whole question around the electrokinetic field potentially that was Thomas Townsend Brown was looking at, and Jeff Menko just finished his book on causality, electromagnetic induction, and gravitation. And it basically says that you should get like a force transient on switching on and off. So on, which is basically like when you turn it on, it's supposed to go in the reverse of the current. So it's Jeff Menko's way of explaining Lenz's law of why when you're doing induction, the current, when it switches, it goes in the opposite direction and stuff. So I was just wondering whether you got that, because it looked like you had it hooked up to an oscilloscope, and that you would have.
Well, what I learned 4 or 5 months ago is that these digital scales and load cells have a very slow sampling time. So what I did was I took the load cell out of the scale. So it's a 5 kilogram load cell, which I've extended off the edge of the bench. And then I made a differential amplifier that's very sensitive and low noise. And I hooked it to the oscilloscope where I can sample at 1 gigasample per second, so that I don't get any aliasing, fake false readings telling me I've lost, 3 grams when it's just bouncing around,
like a high pass, low pass filter type situation.
So I made my own digital scale by connecting the load cell to the oscilloscope. And so what you're looking at on the oscilloscope is basically, if you watch the videos on my YouTube channel, Warp Drive Tech, you'll see me dialing in the 0, which is like the tear on the scale, just getting it's so touchy, but I get it to within a few tens of millivolts of 0. And then I put my 20 gram weight on there, and I, read what it says on the screen, and, it's about 1.5 divisions. And then that's my calibration, and it's rough. I'm not trying to measure it down to the milligram here. I just want to see the effect and know that it's either pushing down on that scale or it's lifting up from it. Here, I expected it to push down, and it did.
Did you see any sort of increase in thrust as you turned it on? Because I think you were turning it on, then leaving it, and then turning it off. Did it kind of go up and then down again? Or
in fact, yesterday, before I could go back to the other video maybe, but yesterday it's before my power supply died, it was arcing inside. You could hear it. There was something breaking down inside, going click, click, click. And each time it did that on the scope, you could see the transient where it was changing the weight, because it was changing the voltage rapidly as it arced over.
Oh, I can tell you. Yeah, I can tell you what that is. It's arcing inside the CW multiplier. It's arcing from one, and that's why you get the voltage drop, because it's.
I don't have a CW multiplier.
Oh, okay.
No, this is just a 30-volt DC power supply, and I'm using a 0 voltage switch board driving a flyback transformer with a sine wave.
It's arcing inside the the coil.
No, but it's not. It's arcing
Right.
in the power supply. I can hear it. It's the RF or the noise. It's not RF. It's like 40 kilohertz, 30 kilohertz, something like that.
Yeah.
That it's switching. That noise and the high voltage that the flyback is generating is giving me a DC offset. In other words, I'm getting an ion cloud inside the box. All right, which is then feeding back through the because it's coupling across an isolation barrier that is, the core is completely isolated from the coil, and I have insulated wire wound on the core. It's completely isolated, but there's enough ionization in there to break over that isolation barrier and feed all the way back to my power supply, making it charged relative to Earth. And because it's got a grounded plug, it's arcing to Earth inside the power supply. And you can hear it. It's going, I keep saying it's going to blow, and it sure enough it did.
A big old party there. Sounds like a lot of fun.
Anyway.
Do you know what the ultrasound is for? Because I know that you guys were speaking a lot about
shaking off ions.
Oh, is it? Oh, okay. Okay.
It's resonance. You want that thing to shake and ionize the air and give you a resonance on that disc that helps to increase the amplitude and spread more ions, like a speaker. All right.
Yeah, I guess you have kind of cymatics, when you've got the plate with the sort of the dust on, and then you can create resonance patterns. I guess you could kind of then do maybe like an ion trap almost in the air.
I did it with salt on the disc at different frequencies, and when you hit resonance, the salt jumps like an inch off the disc. So imagine those are ions in the air bouncing off the disc. It'll help produce a bigger ion cloud. Plus, that ion cloud could be developed into standing waves, which would then concentrate the charge. And so the idea is to develop a standing wave below the disc, where I have a positive cloud above and a negative cloud below, where I can concentrate that charge in the air to cause lift on the center disc. So that's cool. That's my idea of this thing so far.
I thought the ultrasonics could be, because I know there's a relationship between velocity and the electrokinetic sort of vector field as well. So like if it's not just charge density or current, it's also velocity as well. So if you're sort of moving stuff like that, then you're potentially, that's like the same thing as sort of switching on and off quite quickly, but using the velocity aspect of it potentially as well.
Yeah, the force.
Oh, that's cool.
The force that I've come up with, the equation I've come up with is the same as like for a lifter, and it is that the force is proportional to the current, which is proportional to the charge density times the velocity. The current density, the force density. Yeah.
Awesome. No, that's great. Cheers, man. No, thanks for answering my questions.
Well, and thank you as well, Chris. Okay, so Harold, sir, let's go to you next.
Good presentation, Todd.
Hey, Harold.
Question for you is this. Recently, I saw, I think you are in the right track about the Gravifly doing with the ion. And recently in YouTube, I saw a video from a new startup in Doral, Florida, about the ionic propulsion, in which they are selling a drone that can lift 2 pounds, and it has a flight time of 55 minutes and can go several miles. And with lifting 2 pounds, I mean, I'm going for 55 minutes, flight time. I wondered, if you have seen it, what is your relationship with that in relation to the Graviflyer? Because it might explain why the Graviflyer flies the way it does if it's using the ionic propulsion as the main.
Yeah, it didn't. From my understanding, I saw the video and it didn't say much. I didn't read up on it or do any investigation. Mark so-called did some, and he said that it had a blower, like a ducted fan in the middle.
I saw something like that in the middle, yes, but they claim that it's all 100% ionic defined technologies, and I was wondering,
I think my understanding, or what Mark said, was that the ducted fan is what's keeping it up, and they're using the ionic propulsion to steer.
Okay. And because I saw it recently and I wondered, that might, that might explain, why the Graviflyer is floating without the fan. Maybe, the spinning disc or something like that. Or what is the contribution of the spinning disc?
It's my theory right now regarding the Graviflyer is partly what I'm just investigating now, because as you're aware, my objective is I've taken the Graviflyer apart into pieces. I think we just lost Harold.
No, I'm here.
Okay, I've taken it apart into each constructive element and testing it separately, right? So as a combination in the Graviflyer, you've got this what I'm talking about of creating the standing waves and a positive charge cloud above it and a negative charge cloud below it, and then it has a lift between them because the middle disk is charged. But in addition, the spinning magnets generate a magnetic field. The way Alexei draws it, it's like a big donut, Taurus, and as the ions get flung outward by the spinning disks, just like in the Aurora Borealis, those ions spiral and follow the magnetic field lines, creating a electromagnetic Coanda effect. All right, so it generates the disks blow the air outward, but then the magnetic field grabs those ions and pulls them downward, pushing it up.
Well, that's a good metaphor to explain the whole thing. So you're still looking.
We'll see. I don't know. I haven't made one fly yet.
Sounds like a good metaphor for that to explain the whole thing. But I look like you're still looking for the synergy of everything to see what is it exactly.
Yeah, well, I haven't gotten any lift out of the magnets yet. Spinning magnets, charged or uncharged, hasn't given me anything. But
okay.
So far, this test that I showed today with the spiky one is the first time I've seen really any significant amount of weight gain or weight of any kind. So that right now I haven't seen anything on the Graviflyer give me any kind of lift. But I'm not done testing. I got a lot of work to do, and I have a day job. I sell solar power.
Okay. Well, that's good. You're making progress. And you keeping it. It's interesting what you're doing. All right. Hey, thank you for the explanation.
You're welcome.
And good luck.
Thank you.
Okay, let me see. Riccardo, sir.
Yeah. G'day, Todd. I've got a question for you. Let's assume that you get your apparatus to work. So it's flying, it's working. Now let's also assume an application as a drone, as a military drone, right? So you've got it working, it's a military drone. My question is, in such an application, would it produce detectable RF of any description? So could it be targeted?
Oh yeah.
Yeah, right, okay. All right.
Oh yeah.
Right,
it's got to, because it's got to ionize the air. It's going to have a huge fingerprint.
That's what I was thinking. Yeah, that's what I was thinking. Yeah.
But it could be made very quiet, but not electromagnetically quiet.
Yeah. Okay. Thanks for that.
Okay, let me see. Do we have any more questions for Todd? There's Jared. Jared, sir?
Hey, just to follow up on that last part about if they'd be visible, it looks like because of the Tesla coil, it emits a fair amount of microwave RF. So, I mean, you'd be able to see it with radar pretty easily.
Yeah, absolutely.
Yeah, it's basically like a giant flashlight in the EM spectrum. I mean, you know, you could probably see that flyback coming a mile away.
Well, what I'm supposed to get today or tomorrow or Monday is still the same kind of design, but it's a specially made flyback transformer that's rated to 60 kilovolts, not this TV monster. You know, it doesn't have all the extra pins sticking out that cause arcs. So we'll see. I can't wait to get it. I've been waiting a month.
Yeah. Let me see. So do we have more questions? Yeah, well, I think we're doing pretty good. So let me do this then. Let me put this on gallery view, and everyone please give Todd an applause again. A giant applause, sir.
Hey, you.
Thank you for the update. Thank you for coming back. I love it when you present. It's
I'll let you know when I got more to present. This one was a little tough to squeeze in because I went 2 weeks ago and I was pretty much said everything I had up to that. So I just covered what I've done in the last 2 weeks. So
well,